Okay, so to begin this experiment, I have my ink cartridges, the rare earth magnets, my cup, and vegetable oil. So to begin, I'm going to empty one of these into the cup and see how much I get from there. Okay, I bought the wrong thing, but we're going to just roll with the punches here. Now I'm going to add the 2 tablespoons of vegetable oil. And I'm going to mix it. See if this works. Okay, now I'm going to add more ink. Give it another mix. And take my rare earth magnet. And I see the spikes forming, but not as to the same extent as they are in the video. So unfortunately, I don't have a surface in which I can just rub ink on, so I couldn't do the part of the experiment with the table, but I observed what happened in the experiment in the video, and I'm gonna explain the chemistry behind that just to show my knowledge of understanding of the experiment. I also noticed in my experiment that I had some minimal spike formation, but not nearly to the extent as there are in the video, and I think that that's just due to the type of ink toner that was used and also the amount that I had accessible, so I know what I would need to change for the next time to see the types of results that we did in the video that was used as the example. Okay, so in this experiment, we first make a magnetic fluid, or otherwise known as a ferrofluid in this case, which basically contains a bunch of dispersed nanoscale tiny magnetic particles. This magnetic fluid is a colloidal suspension of these magnetic particles within a liquid carrier. So ferrofluids contain these particles that can be prepared by combining amounts of iron 2 salts or iron 3 salts in a basic solution. And essentially, this ferrofluid or magnetic colloid is this stable suspension of magnetic particles in an oil based, in our case in this experiment, we use pure, 100% pure vegetable oil, carrier liquid that is made by combining the two. So outside of a magnetic field, the ferrofluid behaves as any liquid would behave. However, once a container for the ferrofluid is held next to a strong magnetic field, its surface appears to become solid, and that's when we see those spikes that are pointing along. It doesn't look like they're pointing in specific directions, but they're pointing in the direction of the magnetic field lines. So these ferrofluids can be poured onto a magnet as well, and basically be suspended in midair. And we saw this in the experiment in the video, which I just was unable to do. And for reference, I learned that this phenomenon is referred to as the Rosenzweig instability. So in short, when drawn by a magnet, these magnetic particles move their carrier liquid around with them so that the suspension flows as a liquid. However, these particles are paramagnetic, so the magnet does not give them long-term magnetic capabilities. And that's why when we move the magnet away, it goes back to behaving as any liquid would. And we also talk about this in the discussion post this week, why the bonds that are being formed here are not ionic bonds, because there's not a positive and negative charge attracted to one another, but rather a metal in this case, or would be iron.